The Klang Valley Mass Rapid Transit, or KVMRT, is a rail-based public transport that will be the backbone of a new sustainable transport system. MMC Gamuda KVMRT Tunneling Sendirian Berhad was awarded the largest work package by the government to design and construct the 9.5-kilometer underground works for the KVMRT Sungai Buloh Kajang line. The underground tunnel begins at the North Portal in Semantan and ends at the South Portal at Maluri. The tunnel connects 7 underground stations: KL Central, Pasar Seni, Merdeka, Bukit Bintang, Pasar Rakyat, Cochrane and Maluri. The ground conditions from Semantan to Bukit Bintang consist of the Kenny Hill Formation. Earth pressure balanced tunnel boring machines are used to mine in this ground condition. At the Kuala Lumpur Limestone Formation, which stretches from Pasar Rakyat to Maluri, the tunnel will be mined using variable density tunnel boring machines. The boring machines will excavate rocks and soil with special tools fixed on a rotating cutter head, while building permanent walls at the same time. The tunnel wall will consist of 7 segments and a keystone. These segments are produced using steel fiber reinforced concrete, which will enhance the toughness and durability of the tunnel walls. Polypropylene fiber is also added to the concrete to improve fire resistancy of the tunnel. The concrete segments are manufactured by Eastern Pretech Malaysia Sendirian Berhad, SPC Industries Sendirian Berhad, and MDC Precast Industries Sendirian Berhad. At each site, land clearing, soil investigations, the relocation of existing utilities and road diversions had to be carried out before construction processes commence. The Semantan North Portal, located at the intersection of Jalan Duta and Jalan Semantan, is the launch pad for 2 parallel earth pressure balanced TBMs. The portal and its ancillary structures, as well as the logistic area to support mining activities, were completed by early 2013. The earth pressure balanced TBMs from China arrived on site in February 2013, and each TBM took approximately 6 weeks to assemble. Locomotive rails were built to transport materials and supplies into and out of the tunnel. The first earth pressure balanced TBM was launched from the Semantan portal in June 2013, and the second TBM began mining in July the same year. As the TBMs mine, excavated material is transported out of the tunnel by muck cars and stored temporarily in a muck pit before it is removed from the site. The KL Central Station is located in front of Museum Negara underneath Jalan Damansara and has a construction footprint of approximately 2.25 acres. Work on the site started in April 2012. This station is built following the top-down construction method. Construction of the station box and ground anchoring took approximately 6 months to complete. The station box was then excavated down to the roof slab level and king posts were installed. The roof slab was then constructed. Excavation and strutting then continued beneath the roof slab. Located at a popular tourist area, the Pasar Seni station footprint includes the structures of UO Superstore, Plaza Warisan and Klang Bus Terminal. Demolition of the 3 buildings took 6 months to complete. Construction of the station box progressed in stages, starting with the construction of diaphragm walls at the Klang Bus Terminal site. King posts are then piled approximately 24 meters deep into the ground. Temporary struts are installed to support the completed diaphragm wall panels during excavation of the station box. At the Plaza Warisan and UO Superstore sites, reinforced concrete walls had to be constructed at the basement to act as guide walls during trenching for the construction of diaphragm walls. heavy steel poles that go through the basement and piled into the ground support steel decks that were set up at ground levels above. These decks hold the heavy machineries that are used for the diaphragm wall construction. Along Jalan Tun HS Lee, sheet piles were installed to form a temporary protection box for the 132 kilovolt cables located beneath the road. Jet grouting was then done to create a waterproof barrier to protect the cables. The Merdeka station construction area measures about 1.85 acres. Preparatory works started in April 2012. Diaphragm wall construction for the station box was completed in early 2013. King posts were installed along the center of the station box. These steel columns support the temporary struts that help strengthen the station walls against lateral earth pressure during excavation. The Pudu launch shaft is a launching site for 2 tunnel boring machines to mine northwards towards the Merdeka station, and this is also the escape shaft for this line. Preparatory works, including diaphragm wall construction, began in July 2012. With the completion of the diaphragm walls, the shaft was then excavated to approximately 3.7 meters below ground level before the roof slab was constructed. Strutting and excavation of the shaft is then continued beneath the roof slab. The Bukit Bintang Central Station inside Kuala Lumpur's Golden Triangle is at the junction of Jalan Bukit Bintang and Jalan Sultan Ismail. After full possession of the site, road diversions and relocation of utilities were carried out to allow construction of diaphragm wall panels for the station box. A row of king posts is installed at the center of the station box. A special silent piling machine with additional augering capabilities was brought in to install sheet piles. This machine can pile sheet planks into hard ground while causing minimal vibrations and sound, which can potentially affect the high-rise buildings surrounding the site. From here at the Inai launch shaft, 2 variable density TBMs will mine beneath Jalan Bukit Bintang. The shaft construction using secant board piling was completed, followed by controlled rock blasting. The upper shaft was excavated to a depth of 34 meters, while the lower shaft was excavated to a depth of 45 meters. Tunnels are then dug at the base of the shafts where the TBMs will be assembled and fitted in for launching. A slurry treatment plant has been set up to supply the TBMs with bentonite slurry during the mining process. Pasar Rakyat Station is located at the junction of Jalan Tun Razak and Jalan Kampung Pandan. The station box is the largest and deepest and was constructed using secant board piling method. Controlled rock blasting and a surface miner is used for excavation of the station box. The heavy drum studded with carbide teeth on the surface miner machine crushes the hard ground into smaller, manageable size rocks. Approximately 600 cubic meters of waste material is produced daily and then removed from the site. The surface miner is the first of its kind in Malaysia. This site will be excavated to a depth of 45 meters and will churn out the largest amount of waste material in the entire project. The Cochrane Station site has the largest construction footprint, which measures about 14 acres. Work started on the site in May 2012. 4 variable density TBMs will mine northwards and southwards from this station box. After completion of secant board piling for the retaining walls, controlled rock blasting was used to excavate the shaft down to a depth of 30 meters. The first variable density TBM arrived at the Cochrane site in early February 2013. parts of the machine was lifted and lowered into the shaft piece by piece and carefully assembled at the launching platform. Every component was tested to ensure that the machine is in proper working order. The launch of the first variable density TBM was officiated by the Prime Minister of Malaysia, Dato Sri Muhammad Najib bin Tun Abdul Razak, on 30th May 2013. The second variable density TBM was also assembled and began mining in July 2013. As the TBMs mine, tunnel rings are built behind the machine to form the tunnel walls. An extensive piping network was set up to piped bentonite slurry mixed with material excavated by the TBMs to the slurry treatment plant. Here, rock and soil is separated from the slurry and later removed from the site, and clean slurry is recycled back to the TBMs. The slurry treatment plant at Cochrane has the capacity to manufacture 4,000 cubic meters of bentonite slurry per day to service the 4 TBMs at this site. Preparatory works for tunneling towards Maluri at the south end of the shaft began in May 2013. An assembly of the third TBM commenced 2 months later. Mining from Cochrane towards the Maluri South Portal is expected to start by the end of 2013. Located in Cheras, the Maluri MRT station and the integral crossover box measures 9.14 acres. Road diversions were first carried out along Jalan Cheras and includes the building of a temporary bridge across Sungai Kerayong. The secant board piling method is used to construct the perimeters of the station box. At the site in front of the District Police Headquarters, strutting and steel decking has already begun. The Maluri South Portal acts as the transition between the elevated and underground section of the line and as a shaft for retrieving the variable density TBMs from Cochrane. Preparatory works began on the site in April 2012, followed by secant board piling. At the retrieval part of the portal, deep soil mixing is introduced to strengthen the ground, which will allow the TBMs to be easily retrieved. Cement and water is mixed at the mixing stations and injected into the ground via 2 nozzles at the drill head. The drill then mixes the cement mixture with existing soil to form columns of approximately 1 meter in diameter. Deep soil mixing was completed in May 2013 and construction of the portal is moving forward. The Safety, Health and Environment program is an important component of this project. In line with this, safety and emergency teams of each site underwent live fire training conducted by experts. A custom-built steel container supplied by Dragger was used to replicate a tunnel fire condition.
Right now, this simulator right here, we're able to create real-life fire conditions from the very beginning stages of the fire to fully developed, where we actually ignite all the fire gases and create flashover.
Flashover is a condition where an explosive burst occurs when a fire is so hot that gases and smoke ignite.
What we actually try and demonstrate is all the signs of flashover prior to and after. We need to recognize the signs of when we need to withdraw. So this training gives them first-hand experience of when not to put themselves at risk.
We can actually see those real-life smoke conditions, whether it's good smoke that we can go in and we can find the seat of the fire and put it out, or they're so bad that we have to exit. Or we know if there's a life to be saved, we know what we can do with water application to get in and save that life. So it's all about reading your environment.
This training is the first of its kind to be done in Malaysia. Stakeholders management is also another critical component of the project. At Cochrane, a visitor center is set up to provide more information to the public and stakeholders about the tunneling works and current progress. A centralized labour's quarter was completed to accommodate 1,800 labourers that are working on the KVMRT underground works. The underground works for the KVMRT is progressing well and on schedule. All teams from MMC Gamuda KVMRT are working closely together to attain the highest standards in best engineering design.